I am so excited to be here, and I'm so happy that my first event back in front of an audience is in my hometown, Minneapolis, at my home conference, devopsdays Minneapolis. I'm not going to choke up about that, I'm fine. So, let's talk about our mill city. I really feel like once we've talked about the Vasa and how we can overbuild a ship, anything in history is now available for me to nerd out about in a talk. And you are the recipients of a lot of pandemic research. So, our mill city. Oh, helps if I hit the right button. We weren't always a tech hub. Today, the Twin Cities is in fact the home of a significant amount of technology. I'm not saying that we should make Silicon Prairie a thing, because we're not really a prairie and it just bothers my ecological understanding. But you can't say I want a riverine silicone. It doesn't work. But you have more than one employment option. SPS Commerce was just up here talking to you. LaunchDarkly is hiring and will take remote. I'm just saying there's a lot of options here in Minneapolis for technology. And one of the things that I'm constantly telling my California startup-based friends is that there's more technology in things that you think are technology than there are in startups. We have a lot more people working in technology doing things at boring companies that make insurance than we do in hip new companies who make juicero? The settler history of Minneapolis centers on St. Anthony Falls and how we built a city around that. We were a milling hub, starting with timber that we floated down the Mississippi from the forest of northern Minnesota to cut and mill here. At one point, there were at least 35 sawmills operating around St. Anthony Falls, plus a number of flour mills, plus, I found this interesting, 8 factories making prosthetic limbs for mill workers. I'm like, that really says something about how dangerous that job was. OSHA wasn't a thing then. Technically speaking, Minnesota wasn't a thing then either for statehood. But we had this river and these falls, and they drove a lot of power. And as we built out the hub to manage that power and to make it work for us, we added more railroads, and we could pull in resources from further and further away. We didn't just rely on up and down the river. We also had trains coming into Minneapolis all the time. This is what it looked like. This was the city as it was in 1891. And you can see familiar landmarks. You can see the Stone Arch Bridge. You can see where Union Depot, where we go ice skating now, was obviously located. You can see that this was a city that was built on its river. It wasn't a park, it was a beating industrial heart. And it's really interesting for those of us who remember the revitalization of the waterfront from something sort of sketchy to something beautiful, that at one point it was the most vital part of the city. So let's talk about flour milling. Going through history. Yes, this is a talk about technology, but not all technology is computers. I don't know if you noticed that. Keep your eyes open for the oscillations between monoliths and microservices, because it's really interesting to me how, over time, we keep consolidating and splitting and consolidating and splitting in accordance with the different constraints that we have on our systems. Microservices aren't right. Monoliths aren't right. Distributed computing isn't right. They're all right now. They're all the thing that we need to be doing in the moment to meet the constraints we have. So when you are feeling sort of trapped by the architecture that you have, ask yourself if it's because you've been listening to conference buzz, or if it's because it's not meeting the need that you have. So this is a local stone mill, very primitive. This is the original microservice architecture. There would be a miller who took all of the grain from about half a day away. They were located on a river, they had built a mill race, and they were using the power of running water to grind, they said corn, but it was British, it was actually wheat, and other grains to make a sort of coarse flour. Like if you buy stone ground pancakes or something, you know how they're a little gritty and crunchy? That was everything. And this is a hyper-local response to the fact that nobody wants to do this all on their own, but also transportation is hard. So we're basically, it's not compute at the edge, that would be having a mill on your farm, but it's definitely like distributed. Once we can move stuff efficiently, it makes sense to centralize for efficiency. I am fascinated by shaft drive factories because the power keeps going to the shafts, and the speed of the machine that the shaft drives can be moderated based on where you put the belt. You can even reverse the direction of some machines by putting a half twist in them. It's actually kind of inefficient. It depends on whether you're using leather belts or rubber or canvas, or there's a whole bunch of things. But it's also really elegant because it says, here's the power and here's the product. And I have something that mediates between the two of them. I have something that changes how fast this thing goes. This is a lathe. It has to turn pretty fast. Like, to make a lathe efficient, it can't be going slowly. So this same shaft could be driving a lathe that's moving pretty quickly, and also a sewing machine that moves more slowly, or a loom that moves at a different speed altogether. Same power source, different applications. When I'm evaluating software technology, I really want to know if what I'm evaluating is an endpoint, an application, or something that helps me connect to my power source. I think that's one of the things that I still find exciting about feature management and feature flags. After 4+ years at this job, I realized that it's actually not a product. It's actually a way to make your product connect to the things you need. Now that we have a way to do this, let's talk about vertical integration. Is this a picture of a monolith or a set of microservices? Who wants to answer? No? It's a trick question. This is exactly like your architecture, which looks like a set of different behaviors, but is actually completely interdependent on your flow. It's probably a distributed monolith. None of it works without anything else, but also you can replace certain elements. So when you think about how you're building things, it is actually very difficult for any of us to make actual microservices that are actually completely independent. It's so tempting to link it to one central database. And then we have a dependency. It's not a good, true microservice. This is the rebuilt flour mill. We're going to talk about that. But if you look at it, the grain comes in the top, and it goes down, and it goes up, and it goes down. This is the most efficient way we could find to do all of these steps. Distribution and adoption. Even if you make the best thing in the world, it doesn't matter if no one uses it. Minneapolis did not lose its Mill City crown because of a lack of wheat or a lack of power, or even because factories needed retooling. I had this whole thing about how it was so important to keep updating things because you needed to be able to keep your factories modern, because look at what happened to the Ford plant. And then I found out that wasn't actually true. Ford plant didn't need retooling. The Ford plant was just making less profit than, like, the Ranger cost as much to make as the F-150, but you could sell the F-150 for more. I think a lot of us are still angry about that. It's much like the Google Reader problem, like I was using that. What if a small pickup truck? But it was an interesting moment in this talk when I was doing the research. I'm like, I thought that what killed factories was needing to retool, but it's not. What kills factories is a change in business need. Retooling is relatively easy compared to socioeconomic systems, which is actually what kills factories. What we make can be literally the best thing in the world, but if we can't get people to believe that and buy it, it doesn't matter. Gold medal flour is called that because it took all of the awards for the 1 year we had a milling awards system. There was only 1 year because Pillsbury just cleaned up and everybody's like, I don't want to play that game anymore. It's the best flour, like canonically, but maybe we weren't the best milling city anymore because Buffalo, New York was closer to the grain fields of Canada. And that's a really interesting thing to me because I'm like, what if we understood that everything we're making is an ephemeral moment in time and not a physical product? It is an interaction with society. It's not a thing. It isn't a thing unless somebody wants it. So this is DevOps Days. You may be asking yourself, was I going to get to the DevOps eventually? Kind of. This river is still here. We still have St. Anthony Falls, despite a really spirited attempt to undermine it and dig it all out. The Army Corps of Engineers had to go in and put a bunch of concrete under St. Anthony Falls because we had dug so many mill races that we were having erosion problems under the river. It could have gone really badly. So Minneapolis still has St. Anthony Falls. And it's useful to remember that even though everything about the factories and the railroads and the riverfront changed, we're still here and we're still making things, even if they're less tangible. What changed is not the river, but how we use it. This is an original tunnel from one of the A mills. I'm not sure if it was Washburn or Pillsbury. The mill shell was converted into upscale condos, like we do, in 2015, and the construction of those condos included putting a new hydroelectric generator in this pre-existing mill race. This tunnel has been repurposed so that we can make energy for this new set of condos. River's still here, power's still here. The way we're applying it has changed. I think that's so cool. So let me make this really explicit. Business forces are the river. The river is going to keep going. The river ebbs and flows. We're in drought right now. Please don't water your lawn during the day. Just let your grass die. It's a problem anyway. Grass is a stupid crop. But the business forces of the river are our problem, and we have to care about them. And the products are the machines that the river drives. The products are the things that the business forces are convincing us to make. In a world where we can have so many things automatically on our tiny pocket computers, sometimes we still buy books because the market forces say, I like to read a book, I like to smell a book, I like to underline things in a book. So what's going on is that there are still sufficient market forces for printed material. This hotel that we're in gets steam from the Minneapolis district energy system, which is really cool. If you've never looked it up, district energy is really cool. So if you come into downtown in the winter, you know the 3 big smokestacks with the steam billowing out of them all the time, and you're like, what is that? What is that big? Well, it's the heating and cooling for most of the buildings in downtown, including this one. We've centralized that because it is more efficient in a downtown area. When this hotel decides to remodel and maybe, I don't know, figure out their air conditioning, they don't have to think about where to put their generators, where to put all of that water storage, how to manage all of that. They just have to interface with the generation system. There's a bunch of pipes that are essentially the API, and they just have to plug into it. And what every building does with their steam energy or their chilled water is on their own. But we have provided that motive force for them to do that. So products are the machines that end up at the endpoint. Business forces are the river. DevOps is the belt system that goes between them. DevOps exists not just as the intersection between operations and development, but between making things and the people using those things. Because DevOps is and always has been about people. That's why all of the iteration loops that you'll ever look at have monitoring, have observation, have feedback in them. You have to have that feedback coming back, or otherwise you don't have a loop. You just have a waterfall. It's not really how we want to be designing software or delivering products. We really want to be giving people what they need, and in order to know what they need, we have to listen to them when they get it, see how they feel about it, talk to them. And in order to do the best by what we're delivering, in order to have maximum efficiency of the power that we're using, we need to make sure that we're talking not just to the easy users, but to the difficult users, to the people who have elected not to use our stuff. I get as much information talking to people who are like, I don't want to buy your product, as I do talking to the people who do use my product. Because why they don't want to buy my product is important information to me. I don't need everybody to buy my product. If you have a home-built system that's working for you, that's awesome. What does it do? Tell me about it, because I want to learn about what it is people like you need. Every manufacturing process has byproducts. It's something that we can't get away from. Every time we make something we didn't want. So in this case, what we didn't mean to make was flour dust and technical debt. Every factory makes byproducts, even code factories. And byproducts are usually a problem to dispose of, but sometimes we can use them. Like when we do flour milling, we create bran, which frequently gets put into animal feed. So even though we're stripping out some of the things in flour that are less nutritious for us, we're still putting it in to the system, still feeding it back to our animals. When we're doing software, we are inevitably creating technical debt. And I really feel like we've framed technical debt badly, because we feel bad about debt. We say, I want to get out of debt. I can't believe I'm still paying my student loans. Like all of this, investing our capital into the future is a kind of debt, but it's not a bad debt. So when we create technical debt, as long as we have a plan to repay it and keep it under control and stay ahead of the interest, it means that we can build something that we couldn't build without debt. Like, go ahead and try and build your own house without going into some kind of debt. It's not a thing that we can really do. So you can't build software without invoking some kind of technical debt. You just need to be mindful not only of where it is and how you're going to get rid of it, but whether it's the kind you want to be accumulating. Is it high interest rate technical debt? Things like, oh, we don't need to do localization, we're going to code everything in English. That is high interest technical debt, I assure you. Or is it stuff like, okay, we're going to use this framework, it's not a perfect fit, we'll write some shims and we'll fix it later. That's not so bad. Like, eventually the shims either become load-bearing and permanent, or you switch frameworks. But that's okay, that's a choice you made. So when I'm thinking about all of these side effects and these byproducts, I think it's important to remember that it is because we are making something that we have this. There are really only 3 ways to deal with byproducts. If you're managing proactively, it means that you build your entire factory on a different design so that it is handling dust much better. It means building your code with comments and references and hooks for future plans, but not so many that you can't move. The second way is to lie. You can lie about it to yourself or to others. That is certainly an approach that a lot of corporations have taken. I think we're still finding out some pretty horrifying things about water, both what we've already put into our water and what we might be putting into our water if we put pipelines across it. We can lie to ourselves about how bad that's going to be, but that doesn't make it not true. Sometimes, even with good prevention, or even when it's coated in lies, your byproducts explode. And if that happens, you better have a plan for what to do next. This is an artistic rendering of the Washburn A plant blowing up, and what it looked like afterwards. Turns out flower dust doesn't actually explode, technically. It just burns very, 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 very fast. I'm not entirely clear on what the distinction is if it can make a building look like this in a few seconds, but it is. The results are pretty much the same. They heard this explosion on Summit Avenue. The thing about this mill explosion, and this mill was brand new, this mill was like 4 years old. The thing about this mill explosion is that the mill owner, Cadwallader Washburn, showed up the next morning while everything was still sort of gently burning around the edges and swore that he would rebuild. And he did. Within 2 years, Washburn A was back, bigger and better than ever. He imported some kind of flour mill genius from Eastern Europe who did a whole bunch of different stuff with dust collection to make it much safer. That's not because Cadwallader Washburn, the second best name in the story, first best name, Zebulon Pike. I could have been named Zebulon Pike. Anyway, Cadwallader Washburn, not an inherently good-hearted person, didn't actually care that much about Minneapolis. He rebuilt because it made good business sense. There's still a river, there's still a railroad, there's still grain flowing in. This is still the place that I want to be doing this business. He wasn't a bad guy. He did, in fact, take care of the families of the 14 people who were killed. Well, 12. Some of them were in other mills after the first one caught fire and blew up. Mills next door caught fire and blew up. Fortunately, it was the evening, so the death toll was low. Once the fire is out, what happens? DevOps and HugOps and chaos engineering and blameless culture and observability and circuit breaker software systems are all about the fact that sometimes, despite our shiny new systems and our best good faith efforts, sometimes everything blows up. Sometimes we have to accept that failure is an inevitable part of doing anything. Sometimes we know that we've done our best and circumstances or inability have conspired against us to create a failure. We need to have a plan for what happens after that. And I really love the DevOps culture of how do we handle that? How do we deal with that fact that there will be failure? Not even can we mitigate it, but like, can we mandate this away? Can we have enough process, enough change management board that we never make a bad deploy? No, you can't. You cannot. There is not enough slow, careful work in the world to save you from problems. The thing, counterintuitively, that saves you from problems is going faster. Going faster like riding a bike, making every change a smaller bet so that you can keep going and keep moving. And if it's smaller, it's easier. If one tiny riverside mill blew up, it wasn't a big deal. I mean, it was for the miller, but it wasn't like 30% of America's flour supply was suddenly like atomized across Minneapolis. If you have a smaller thing, you can take bigger risks. So now what? What am I proposing? Like, that seems extremely historical and interesting, but not actually very actionable. So here's what we do. For future-proofing, put in changeable coupling. You want to be able to change the belts between your business driver and your output, because that's the place that you get a lot of friction. You want to be aware of distribution and how you're making things get out in the world. Is there a rail line? Is there a change in regulation? What is going on? You can't just be your company because you exist in a system. Risk mitigation. You know that there will be failure, so given that, how do you make the failures as gentle as possible? How do you take the flower dust out of the air? How do you keep things as safe as possible? And market responsiveness. How do you make sure you're making the right thing? Are you asking? I really loved Ian's emphasis on asking people what it is they need, instead of telling them what they might want. Because we don't know until we've been there what it is that we need. If you don't have that, you don't have a mill, you probably don't even have a feature factory. What you have is a river of vast potential, and you need a way to build a way to use that power without locking yourself in or collapsing half the river. So if this talk was too long and you read Twitter instead, because I know all of you online read your email while you were listening, because I've been in these talks, here's the takeaway. Decouple your products. Not just your production, not just your environments. Decouple your products so you can understand what you're making is different than how you're making it. And remember, as we have learned so importantly this year and in flour mill explosions all over, air circulation matters. It really matters to have some airflow and to know what's in it. So, thank you very much for your time. If you'd like more information on this, you can come see us in the booth, or you can visit this URL. Thanks.